So I'm going to start here with this green, doing exactly what we did. This problem has a little wrinkle, which we'll get to in a second, but until then we are totally good. So just do exactly what we did. I would encourage people to do one step at a time, but ultimately it's your choice. So here's what I got. I'm now going to do this brown piece. Here's what I got for the brown spot. And please stop me with questions. I'm now going to just do a little rewrite, nothing too formal. Just going to rewrite as this. Remember, any number can be written as a fraction over 1. Any number can just be written as a fraction over 1, because anything divided by 1 is itself. Okay? So now we are going to simplify, and the best way to simplify is try to rewrite what I'm underlining in orange using only sign. I'm going to freeze it here. Try to rewrite the orange using only sign. So get rid of this cosecant. Here's what I got on the rewrite. Now complete the algebra 1 of multiplying two fractions. Complete the algebra 1 of multiplying the two fractions. Sorry. Complete the algebra 1 of multiplying these two fractions on the left. I hope you get this, which I'll release in 1 second. So I hope you get this. Again, stop me if you're confused. You must stop me. I'm not trying to read minds here. Brianna? This one? Why does the squared go away? Someone answer George's question. Why does the squared go away? Chepe? Yeah, exactly. So when you have a fraction, you can cancel out like this. Brianna? Chepe, one more time. Explanation. To put it differently, what Chepe said exactly right. I'll just like put it in words. Write down what he said. He said basically you have this. So I'm basically saying let u equal sine of x. So you got negative u squared over 1. Brianna, please look up here. Others who have questions. So we're saying let u equal sine of x. So when you multiply this, you have negative u squared over u, which is the same as negative u times u over u. These u's go away. You're left with negative u. What was u? Sine of x. That's exactly what Chepe said, except in pictures. And now we can do the same thing over here. You can rewrite what I've underlined in beige using only tangents. You can rewrite what I've underlined in beige using only tangents. Let's see what you get. Didn't change the purple at all. And here we are. And now, complete the algebra here. Complete the algebra there. What happened? You have a question? No. That's one way to express your answer. Another way to express the answer is both equally right. I don't think one is any better than the other. Either of these would be acceptable. Questions? Yep, Mr. Bennett? Because cotangent is the exact same as 1 divided by tangent? Is that a yes to make sense, Anthony? Okay. Questions?
So all the time you switch on, it's gonna be like code, like you did with, because at first it was cosecant, right? And then you changed it to sine.
Yes, because I wanted the cancellation. Yep. Right. Exactly. Because I wanted the cancellation. Absolutely right. All right. So that takes us through number 7. So let's push into the Pythagorean identities. So this is something new. So Pythagorean identities. Pythagorean identities. Pythagorean identities. There are 3 Pythagorean identities to know, and I'll prove how we get them. So imagine we take a triangle here. This is the proof. I'll let you know when we actually get to the 3 identities. So we have a right triangle here, ABC. Let's take 10 seconds. Next to the triangle, please write the Pythagorean theorem. So please write the Pythagorean theorem to the right of the right triangle. And here's what we've got. And now here comes the proof. So what we need to do here is we just need to divide everything by c squared. So we have a squared over c squared plus b squared over c squared equals 1. A squared over c squared plus b squared over c squared equals 1. Now, let me rewrite this, which will say, I'm going to write something that's mathematically equivalent, just looks a little bit different. I'm going to write this as this. This is mathematically equivalent. I'm just saying a squared over c squared is the same as a over c squared plus b over c squared. Let's pause right here and ask a different question. If we said what is sine of theta in terms of letters of the triangle, don't shout it out, and cosine of theta in terms of letters of the triangle, please write that down. If somebody said what is sine of theta in letters, you would say something. If somebody said what is cosine of theta in letters, you would say something. Remember SOHCAHTOA. And hopefully you come up with SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and you end up with this. So, and here comes the final step. A over C, another way of writing that is what? This is sine of theta squared plus cosine of theta squared equals 1. This is the first Pythagorean identity. There will be two more. This is true for any angle. Identities are true for any angle. That's the first Pythagorean identity. Questions? Okay. There are two more Pythagorean identities, and here's how we get them. The second Pythagorean identity, so here's the first one. I'm just going to rewrite that again. Right? And simply, we're just going to divide everything by sine squared. Just divide everything by sine squared theta. So, sine squared theta divided by sine squared theta is 1. Cosine squared theta over sine squared theta is cotangent squared theta, because cosine over sine is cotangent. And 1 over sine, well, 1 over sine is cosecant, so this is just cosecant squared theta. This right here is the second Pythagorean identity. And the third Pythagorean identity is take the first one and divide by cosine squared instead of sine squared. So take the first one and divide by cosine squared. Sine squared over cosine squared is tan squared. Cosine over cosine is 1, and 1 over cosine is secant. And here is your third Pythagorean identity. Let's take questions on any of the three.
Can you show the first one?
Yeah. Eddie? All right. No more questions? Okay. So let's jump right in and do some problems. So number 1 on part 5. Says secant squared of x minus 1 over secant squared of x. Take a 1-minute break and we'll come back in a minute. Alright, so the goal of these problems is to simplify into either one trig function or one number. Your choice. I mean, not your choice. The problem will dictate. But you will end up either with a number or one trig function. So let's jump in and see what happens here. There's no math for how to solve these problems. There's no one way that says do these 5 steps and then you get it right. Like life,